My guest today is Melanie Mitchell, a professor at the Santa Fe Institute, author of Complexity, a Guided Tour, and Artificial Intelligence, a Guide for Thinking Humans. Melanie studied under the legendary John Holland and has become one of the leading voices bridging complexity science with research in artificial intelligence. In our conversation, Melanie and I explore the fundamental nature of intelligence and why today's AI systems may not be as intelligent as they appear. We discuss the persistent misunderstandings around modern AI, the concept of jagged intelligence, and why the Turing Test is misleading us. We also talk about embodiment, metacognition, and how complexity science principles, like emergence, could reshape our approach to building truly intelligent machines. Finally, we delve into what biology can teach us about creating more sustainable and genuinely intelligent artificial systems. I hope you enjoy our discussion. Melanie, thank you so very much for coming on the podcast. It's a real pleasure. As we will see today, you are known for merging complexity science with algorithms and AI and other topics and technologies. I must say that to everyone out there, if you haven't read yet Complexity, a Guided Tour, which is a book you published a couple of years ago, I think it's a real masterpiece, and I'm not using that word very often. So please have a look at that, which makes me want to ask you kind of a first question before we talk about everything I want to discuss with you. You had as a PhD supervisor, John Holland. Is there anything specific you'd like to share about your experience with him?
Yeah, John Holland was incredibly influential for me. He got me into the field of complexity. He was a professor at University of Michigan when I was a graduate student there, and he was a wonderful advisor and also just a really good person. As you say, he was extremely generous and happy to share his knowledge, incredibly enthusiastic about everything having to do with complex systems. And he died a few years ago, and I really miss him.
I believe he was the first person to ever got a PhD in computer science in the United States.
Yeah, it's hard to say exactly, but he's certainly one of the first. Exactly.
Yeah, there is a quote from him that I like and I use a lot, which is, "If it's in equilibrium, it must be dead."
Yeah, exactly.
That one is so good.
Yeah.
All right. On that, so what I've done is that I divided my questions in three different parts. First, I want to talk about the fundamental nature of intelligence. Then part 2 will be dedicated to the current approaches to AI and whether actually they make sense considering the fundamental nature of intelligence. And part 3 has to be about combining the two, which will look into the future, whether AI should or maybe should not be reoriented to better account for the nature of intelligence. So starting with the nature of intelligence, in Artificial Intelligence, a Guide for Thinking Humans, another of your books, you critique many popular claims around AI. And my question is this: what do you see as the most persistent misunderstanding around today's AI systems?
Yeah, today's AI systems are incredibly good users of language. You can chat with them and they really seem like they are understanding and thinking the way we do because they talk in a lot of ways like we do. But I think we have to be very aware that we tend to project intelligence, understanding, consciousness, all those things onto entities that communicate with us in natural language. And that's been true throughout the history of AI, not just now, but it's even more important now because these systems are such good and fluent language users. So we tend to assume that something that can use language so fluently also would have other kinds of cognitive characteristics or cognitive capabilities. And we're often surprised when these systems show limitations in their cognition, because it seems, given their behavior, that they should be able to do certain things which they can't. And there's a new buzzword in the field of AI, which is jagged intelligence. And that's a way of describing a system that, instead of having the kinds of intelligence we would predict, their intelligence is rather very jagged in that it's very high in some areas, but extremely low in other areas that surprise us. So I guess the short answer is these systems are not like us. They don't think like us, if you could even say they are thinking at all. They don't understand the world like we do, and that shows in some of their surprising behavior.
And is that a critique somehow of the Turing tests?
Yeah, I think the Turing test was making the assumption if something was communicating with you in language that seemed human, that why not then say it can think, it can understand. But I think it's been shown many times with many different kinds of Turing tests that the Turing test is more a test of our own tendency to project intelligence onto things that are not, in fact, intelligent.
And it may be, I suppose, the first time that indeed we have a thing that can reach such good capacity for language. And so therefore, this may be why we are assuming that there is understanding and thinking behind. You actually warned a couple of years ago about anthropomorphizing AI. You said that it can lead to confusion. It seems to me that as those systems scale, it seems to be harder and harder to maintain indeed a clear thinking in what they can and cannot do. Is there a way for us out of that issue, or are we doomed to think that they are human when in fact they are not?
Well, we humans tend to anthropomorphize quite a bit. We look at our pets and we assume we know what they're thinking because we assume that they're somewhat similar to us. Oh, my dog is really hoping that I'll take him for a walk, or really mad that I left him for 4 hours. We assume we understand the other biological systems, when in fact maybe we're anthropomorphizing them too much. And with language attached, that makes our tendency even more strong. It's hard not to use terms like they're thinking, or they understood me, or they want something, or they believe something, to use these kinds of mentalistic terms. There's a lot of controversy, of course, in the AI community over whether those terms are warranted. Some people who I respect very much and think very deeply do believe that they are indeed thinking, that it's crazy not to say they're thinking. Other people say that's just the wrong way to talk about them at all. One of the problems is we don't have great ways to test for the presence of kinds of mental capacities we attribute to these systems. How do I know if it understands? How do I know if it's conscious? How do I know if it is thinking in some human-like way? And we often conceptualize computer systems as intelligent agents, but there's other metaphors that we might use. So, for instance, the psychologist Alison Gopnik says that thinking of these systems as intelligent agents is just the wrong category, that instead we should think of them as what she calls cultural technologies, which are more like libraries or encyclopedias or writing systems, things that compress sort of the results of human cognition, all the text and images and so on that these systems have been trained on, and make it much easier for us to access the whole of human knowledge. So I think the way that you think about these systems, you should be aware of the metaphors that you're using to conceptualize what they are.
Yeah. And when it comes to the test, I've seen here and there in the press people using as a methodology just asking a question: are you real? Are you thinking? And of course the system will tell you, yes, I am, which is not a guarantee at all that there is a thinking behind. But we do indeed equate language with intelligence. When people express themselves in a language that is not their native language, they seem dumb, when, well, they're not. It's just that they are not speaking their native language. So we've been doing that for a very long time. I hope there is maybe a way out.
Or if someone's disabled and has problems constructing grammatical sentences or coming up with words, we also make assumptions about their intelligence, which are unwarranted. So yeah, language is the way that we interact with other humans, and it often produces wrong stereotypes or wrong conceptions of who they are and what they are doing.
Talking about whether they are intelligent and the fact that, well, not so much, and maybe they should indeed be seen as embedding in our culture and seen as libraries, there is, of course, a big debate as to whether they might then become intelligent one day, which some people may call AGI or general purpose AI system, as we call them in the EU AI Act. You have actually a publication entitled Why AI is Harder Than We Think, in which you argue that narrow intelligence is not on a continuum with general intelligence, and that in fact we do not know how complex our thought process is, which means that being able to achieve AGI is something which is far away, if at all possible. Do you have any thought on that? Should we care about it? Should we even talk about it right now, or should we just let go of this idea?
Yeah, so there's a lot of layers of that question. Let me start with the idea of narrow intelligence. In the past, people thought many times that a particular kind of capability would be indicative of general intelligence. So, as an example, in the 1970s, a lot of people were saying that if we could get a computer to play chess at a grandmaster level, that's kind of an indicator of human general intelligence. People thought that would be an indicator that we were close to human level intelligence more generally in machines. And of course, it happened. We got a computer to play chess better than any human, but that didn't mean that it had any general intelligence whatsoever. And I think that taught us something about what we meant by general intelligence. And the same thing is happening with language. We assume that if something can converse with us in fluent language, it has to have some kind of general intelligence. And that's now being shown not to be true, that we have systems that can converse with us, and yet they don't have what we would call general intelligence. Now, another layer of this is, what do we mean by general intelligence? We humans are not very general. There's a lot of things that we're quite good at. There's a lot of things that we're quite bad at. And that's the same for any biological intelligence. So you could argue that there's no such thing as general intelligence. There's only intelligence in a specific kind of ecological niche. We're very good at social intelligence, but often quite bad at, say, estimating probabilities or something like that. So I think when people talk about AGI, artificial general intelligence, it's not totally clear what they're talking about. Are they talking about matching sort of human intelligence? Are they talking about something greater than human intelligence that can, in some sense, magically do everything? I don't think that's possible. That term has been used in so many different ways that it's almost lost meaning. In terms of human level intelligence, I think there's been some sort of backtracking in the AI world. In the early days of AI, that term meant everything we do, not just so-called cognitive tasks. It include all of the physical intelligence that we showed, things that we did with our bodies in the world. Nowadays, people are equating intelligence in the AI sense with something that's not embodied, that's like a brain in a vat, that doesn't have any active interaction with the world. That's the kind of thing that AI has associated with intelligence, but it's somewhat different from the way many people in cognitive science think about what intelligence is. And it's not just what we do, but it's a subset of what we do. It's maybe proving math theorems or reasoning about some logical propositions and sort of the things that Western society tends to put on a pedestal, sort of this sort of perfect rational thinking, but is actually somewhat different from what we actually do.
And I would love to see indeed a foundation model developed by some company in Africa with totally different value and way of thinking what is intelligence and how we could use that. Okay, let me move on to the current approaches to AI, which is where I bring in your computer science expertise a bit more. we then can talk about whether it makes sense what we are doing right now and the way we try to scale AI, considering the fundamental nature of intelligence that we just discussed. Do you think there is a path to more intelligent system under the current paradigm, or would it require at some point that we find a new one because the current one will soon be reaching its limits?
Well, again, this is controversial in the AI community. I personally think that we do need sort of new paradigms, that one of the things that's strongly lacking in these systems is what we call metacognition. That is understanding your own thought processes, being able to control your own thought processes, having some notion of, say, how confident you are about something that you say or do. These systems lack that. And that's one of the issues with what people have called hallucinations, which are when these AI systems like ChatGPT will generate things and sound perfectly confident about them, but those things are false. We've seen that in many examples, and people have called that hallucinations or confabulations. But the real problem is it doesn't have any notion of what's true and what's false. It just has statistical associations with certain kinds of statements that say they're more likely to be generated and statistically are more likely to be true. But often these systems just don't know if something they say has any relation to the real world or not. So that kind of thing, I don't think we can solve with the current paradigm, that we have to have some new ways of imbuing these systems with more metacognitive abilities. And there's many other things that seem to be lacking in these systems. You know, they learn about the world only through language. It's not clear that is going to be able to scale all the way to more general kinds of intelligence. And even with multimodal systems that incorporate images and other modalities, we haven't seen that's addressing many of the limitations of the language-only systems. So perhaps we have to have a new way to have these systems incorporate different kinds of data about the world. One of the things about the current systems we have is that they take enormous amounts of data and energy to be trained and to run. And that's very different than we humans. We humans don't require so much language data, and maybe several orders of magnitude less to learn about the world. And we also don't require so much energy. I think it's been said that our brains run on something like 20 watts, whereas companies like Microsoft are trying to acquire nuclear power plants to run their AI systems. That seems like something's wrong there. And I think that new paradigms are going to be needed to make these systems sustainable. The way that they learn is enormously inefficient. And perhaps one of the reasons for that is it's quite passive. We feed them language, and they learn from the language that we feed them, or we feed them images or whatever data. And they don't get to choose what data they want to learn on. They don't themselves, like children, seek out data that they want to learn about and ask questions about it and show curiosity or show any kind of motivation for making sense of what they're learning in a more general way. So I think getting inspiration from the way that biological systems learn, especially humans, would be very useful in making these systems much more efficient at learning.
The fact that they do not have a meta thought process is actually very clear when they make a mistake and you point the mistake to them. You do see that they indeed reply immediately, "Oh, you're right," and they give you the exact opposite of what I just said in a perfectly confident manner.
Yeah.
So it seems that there are limitations, and sure, you have DeepSeek and others that are actually reportedly training their foundation models on top of others, but still, you are making a point that the current architecture seems to be limited. And so I guess the question I want to ask is, how do you reconcile the fact that this architecture is limited because of what we just discussed compared to the success that they have?
Well, I think that when people use these systems in real world situations, they are seeing some of the limitations with dealing with novelty or dealing with kinds of situations quite different from what they've been trained on. And also, I think people are already trying to create different paradigms just because of these limitations that we've talked about and the insane energy needs of these systems, which is not going to scale. So I think that's really pushing people to think in new ways about AI. So maybe it will be economic incentives. Maybe it will be customers reacting negatively about the products that are being forced upon them and the way that they have limitations. I think that we're sort of presented with AI as an inevitability. It's being pushed on us in all facets of our lives by big companies that are trying to commercialize these systems. And I think we have agency. We have ways to sort of resist and say, this isn't what we want. We don't want our lives to be run by untrustworthy, unreliable AI systems.
During lunch break today, a couple of my colleagues were playing Rubik's Cube. And as an observer, I took a picture of the game and I said, what should I do if I were to play? And I tried with Claude and ChatGPT, and both of those systems actually said, well, this is what you could do. However, this will be against the rules. Therefore, this is illegal behavior in the game. And so I thought the system would be able to give me what would be the best strategy, but they could not actually come up with anything meaningful. But back to what you said on the big tech companies and the fact that indeed you see the ecosystem being more and more in the form of a oligopoly, if not a monopoly, for lots of, I think, economic reasons, including increasing returns and a lot that relates to complexity economics. It seems that your work suggests that scaling in nature actually comes often from distributed adaptive processes. So back to AI, do you think that we are focusing too much on centralized monolithic scaling in AI, or is it maybe okay if we do that?
I think if we want to take inspiration from human intelligence or even animal intelligence, a lot of what our intelligence is social. Any individual human probably is not that intelligent in it, but there's a lot of things that I can't do by myself. But I'm in a social network where I know who can do that, who has that expertise, and I know how to get in touch with them and get them to help me. That's really more social intelligence or collective intelligence. And so a lot of our own intelligence is not monolithic, it's distributed and it's social. I think that's perhaps why we as a society become, in some sense, more and more intelligent. It's not that the individual is, but it's that the society is through what might be called cultural technologies, that we now have things like the internet that we can use to augment our own intelligences through this big, giant, socially embedded network. And I think that's probably a really important strategy in general for increasing intelligence. And that's something that AI companies are indeed looking at. How do we distribute intelligence over a population of machines or agents instead of having just like this one sort of atomic super intelligent agent like the ones that maybe you see in movies?
Is there a limit to what we can learn from biology or the world around us when it comes to the creation of AI, do you see any strong mistakes that we can make here, or should we engage more at all costs in this kind of thought process?
Well, this is a big debate. How much should you take from what you know about biological intelligence or human intelligence? And how much should you just let the systems learn from data or from interacting with the world? And there's a famous notion in AI called the bitter lesson, which was first coined by Richard Sutton, who's a pretty famous AI researcher. He proposed that all of the attempts we've made to build in intelligence from the top down, like all of symbolic AI, where we were actually programming systems with rules that we thought were important, work much less well than when we just have big neural networks that learn from data and we don't try to build anything in. And that's been called the bitter lesson, because it's bitter because people thought that they could program in intelligence, or that their knowledge of something like linguistics or mathematics or something could help them put in the right components. But that hasn't worked well. And I think that's true to an extent. But I do think that some of the limitations that we see in AI today do come from a lack of inspirations from human intelligence, like this lack of metacognitive abilities, and that there is a role for inspiration, but we don't quite know exactly how to balance these two forces, data and learning from experience rather than building things in. Actually does seem to work better now, but maybe we have to figure out new ways of using these inspirations that we know have worked in the biological world.
You've mentioned this idea of metacognition. It's something that I've experimented with because I read about it and I thought this was an interesting idea in the classroom. When my students use ChatGPT, I then, at the end of the class, ask them, how does it feel to use ChatGPT for that specific task? And for some, they would say, well, it feels great because I could save time in just fixing the typos. But for some others, they would say it didn't feel quite right. And it's, I think, a good way for them to indeed reflect on the use they want to make of it and therefore use it in a more careful way, which is exactly what ChatGPT itself couldn't do, right?
Yeah.
You cannot prompt the system, how do you feel about answering a prompt to which you really have no clue? Let me now move on to part 3 of the conversation. And here and there already we hinted as to what may be new ways to reorient AI to make it more useful, more intelligent if desired. And something you've mentioned is that intelligence comes also from embodied experiences. So now the question, which will become very obvious as the capacity to build robots will augment, is whether any AI system should be embodied somewhere in the form of a robot that will actually have senses and send more data to the system, or whether we want to explore another path.
Right. Well, when we talk about embodiment, again, that's a word that can mean many different things. And often the people who study embodied cognition take into account our particular kinds of bodies and the particular kinds of experiences we have in the world. And I'm not sure that just sticking AI systems into robots and letting the robots navigate around will be that kind of embodiment. Our embodiment is quite complex. Our nervous systems that are not just in the head, but throughout the body, it's very complex. And it's not clear right now what aspect of that complexity is important for our intelligence. There's a lot of debate about that. So I don't know if just robotics, the way it's being done now, is going to be the solution to embodied intelligence. It really depends how it's done. And it may be that the important thing is not necessarily having a body, whether it be human or robotic, but it might be the ability to figure out how to intervene in the world. So there's a nice idea in cognitive science, the developmental cognitive science that I like, which is that babies are little scientists. They are driven to understand the world. They do experiments like dropping their Cheerios from their high chair to see what happens. And they're not only physical experiments, they're also social experiments. They do a lot of experiments to see how the people around them will react. And that intervening in the world, along with the drive to understand the world in a causal way, is part of what gives rise to our kind of understanding and extraction of meaning. So that might be at least one way to try and make machines more robust and understand better, is to give them some kind of drive to understand, which they don't have now. And I don't think anyone knows really how to do that. To give them some drive for curiosity, which is what humans have, certainly, and other animals, and to give them the ability to actually do things in the world and make sense of the results.
What about then the merging of human and technology? I'm thinking chips in the brain. Would it be a solution? And I guess another way of asking the question is, if you were hired by one of the big tech companies and they were telling you, okay, Melanie, you have to find a way so that we can give AI a drive, what would you do? Is there anything you would like to try if you had unlimited budget?
That's a hard question. I mean, in a way, I'm already in that situation in that I work for a research institute and I have limited budget. But I very much have the perspective of trying to understand people and understand what people do. And one of the things that we know about people is that they are very good at abstracting knowledge from data or concepts. And perhaps one of the reasons we do that is because of our limitations. Our working memory is very limited. We're not able to memorize huge amounts of knowledge or experience. We have to rely on abstractions, more compressed versions of the concepts that we use. And perhaps those kinds of limitations will be important. Instead of giving systems the ability to just brute force their way through understanding the world. One example of this is there was this observation that large language models, via their training data, somehow were able to do arithmetic. They were never trained to do arithmetic, but you can give them a little arithmetic problem and they can, most of the time, solve it. How do they do it? Well, it turns out, according to some recent studies, that they don't sort of have an emergent calculator among their neural network weights, but instead they are using vast numbers of very specific rules about how to do arithmetic that don't generalize. So they make mistakes when you start to make the numbers bigger. But the reason they can create those vast numbers of very specific rules is that they have this enormous capacity for learning statistical associations. And perhaps that capacity, which is what makes them succeed, is actually also limiting them because they don't have that pressure to abstract and be more parsimonious in their carrying out their capacities.
Yeah, I like that a lot. So then what about using technology to better understand human cognition and better maybe document which of our human limitations are actually serving a purpose. Is that a possibility? Is that something we should explore?
Yeah, I think that's something that's already happened in the history of AI. We've certainly learned a lot about our own intelligence, either by challenging our assumptions that a certain kind of capacity requires certain kinds of intelligence. There's been some theories in linguistics over the decades that you need very special kinds of brain architectures to learn language. And it turns out that's wrong, because these machines have learned to use language without that. They've just learned it from data and not having these specific brain architectures. I think in the future, people are going to learn a lot about our own intelligence from trying to give machines this kind of capability, because we'll either learn that we were wrong about how we thought about these things, or that perhaps we were right. There's a theory that all of our intelligence is basically our ability to predict what's going to happen in a situation, predict the next word in text, whatever. And maybe machines will show us that that's the case too. So I do think that AI is, as much as anything, it's a way to explore our own intelligence and challenge our assumptions about it.
Yeah, and we may see a positive feedback loop where we therefore better understand how we function and our intelligence, which may make those systems better, which we can then use, which makes me want to ask you a final question, taking a step back and looking at complexity science. You've spent your career studying how systems, whether biological, artificial, conceptual, grow and adapt. Reflecting a bit on what you've done over the last couple of years, what's the one principle from complexity science that you think AI researchers need most to understand?
So one really important idea in complex systems is the notion of emergence. And what emergence means in complex systems is that you have different kind of levels of operation of a system. So let's think about, for instance, molecules interacting. That's one level. But what emerges out of that are higher level concepts, like, for instance, the notion of temperature or pressure or thermodynamics. And what emergence means is that you can take a system and understand it at this higher level and develop theories at this higher level. We have a theory of thermodynamics that doesn't talk about molecules. It only talks about these higher level emergent properties like temperature, pressure, etc. That's key to understanding complex systems. People talk about emergence in AI, but what they usually mean by it is, oh, we didn't expect this particular capacity, and somehow as we increased the size of the neural network, suddenly the neural network had this capacity. But that's a very weak notion of emergence. It's not one that involves understanding how that capacity came to being through the development of these kind of emergent properties that go beyond just looking at weights in a neural network. So I think one of the most important things for AI systems, for us to understand AI and for us to even be able to improve AI systems, is to figure out these more effective theories that involve higher level concepts, such as circuits or vocabulary we don't even have yet to describe what these very complex neural networks are doing. So I think some of the approaches of complex systems are going to be very useful in trying to accomplish that.
Okay, I can't resist but to ask then another final question. Where do you hope to advance science the most in the coming years? Is it something related to emergence or something else?
That's a great question. I want to understand these very new complex systems that humans have engineered. They're not natural systems, they're engineered systems, and yet we still don't understand them. So I think advancing that kind of understanding, and I think that can be done in various ways, both looking at the behavior of them and also trying to look under the hood, as to look at what's going on inside and what vocabulary do we need to make sense of it. Yeah, those are the kinds of things that kind of drive me in my own research.
Yeah. And do you feel that you have access to the data and all you need, or is that a barrier? Good.
I think there has been a big emphasis on we need huge amounts of data, we need huge amounts of computation. But in other areas of science, a lot of understanding has come out of looking at the more simple, in some sense, model systems, as they're called. In physics, we have things like the Ising model, which is a very simple model of magnetism, but looking at it and trying to understand how it works has created immense new ways of understanding real world systems. So I'm more of the opinion that we should try and understand the simplest models first and take that understanding to try and apply progressively to more complex systems. I'm looking at more what people might call toy systems. And I think there's still a ways to go to even understand these simpler systems.
Okay, I want to put on the record that if there is one person I trust to advance science in the field, that's exactly you. So let me put that out there, and we'll reconvene in a couple of years and see what you've achieved. But I'm sure it's going to be fascinating. Again, your work is a real inspiration. It's the kind of work that gives you many more research ideas and insights into so many different complex systems. So I'm most grateful for that, also for your time.
Well, thank you so much. It's been a great conversation.
Yes, thank you very much. And so to everyone out there, as always, take care of yourself, and if you can, someone else too. Bye-bye.